Hello everyone, welcome back to my channel, Your Own Home Tutor. Today we will be learning integers part 2 for class 7 ICSE. So this is a continuation video of the part 1 from integers. The topics which we will be covering in this lecture are the closure property, commutative property and associative property, distributive property of the fundamental operations addition, subtraction, multiplication and division of integers. Then we will cover additive identity, additive inverse, multiplicative identity and some important points related to multiplication and divisions. So let's begin with the first property of the integers, which is closure property. So we will be seeing the closure property for addition, subtraction, multiplication and division. What does the closure property say? Before going to the explanation, we will note that a and b are any two integers, positive or negative. So if we see here, the closure property says that if a and b are two integers and if we add them, then the result which will come, that will also be an integer. This is the definition of closure property. So let us see here how the addition is following or obeying closure property. So if you see here, I have taken a as 13 and b as 9. So if I add a and b together, then I will get 13 plus 9, which is 22. 13 and 9 both were integers and their result is also an integer. So we can say that the closure property holds for addition operation. Now again, if we take two integers, 13 and minus 9, and try to add them, here 13 plus minus 9. So it will give me 13 minus 9, which is 6. This is again an integer. Now coming to the third example, we have taken a as minus 17 and b as minus 9. So now if I add these two integers, I should get another integer. So minus 17 minus 9 will give me minus 26. This is also an integer. So we can say that addition obeys the closure property. Let us see if subtraction holds for the closure property. So the rule says that if I subtract two integers a and b, then the result will also be an integer. So let us see that. A is 15 and b is 6. If I take away b from a, then I will get 15 minus 6, which comes out to be 9. So this is an integer. Again, moving to the second example, a minus b will be 23 minus of 6. This will be 23 plus 6, that is 29. This is also an integer. Again, third example, a is equal to minus 75 and b is equal to minus 30. So if I subtract these two, then what I get? Minus 75 minus of minus 30, that is equal to minus 75 minus plus 30. Different signed integers will get subtracted. The result will be 45. Minus 75 because is greater than 30. So the mod value of minus 75 is greater than 30. So we will put a negative sign here. So minus 45 is again an integer. So in all the three examples, we saw that after subtracting two integers, we are always getting an integer. So the closure property also holds for subtraction. Now let's see the closure property for multiplication. If a and b are two integers, then their result or the product should also be an integer. Let us take the first example. A is equal to 3 and b is equal to 6. If I multiply a with b, then I get 3 into 6, which is 18, an integer. Again, the second example, a is equal to minus 2 and b is equal to 5. So I am taking a positive and a negative integer. If I multiply them, I'll get a negative integer. Looking at the third example, will be minus 3 into minus 4. Minus multiplication will give me positive integer and 3 4s are 12. This is also an integer. Now a into b, a is a negative integer and b is 0. If I multiply these, then I get 0. So in all the 4 examples, we saw that if we are multiplying 2 integers, we are getting the product which is also an integer. So the closure property holds for multiplication as well. Now let us see if the closure property holds for division. Here a and b are 2 integers. In the first example, we will take a as 12 and b as -3. For the closure property to hold, we should get an integer after dividing a with b. So now, if you note here, if I divide a with b, then 12 divided by -3. So any positive integer when divided by a negative integer will give me a negative answer or quotient. So the answer comes out to be -4. So in this case, we see that the closure property is holding. Again, for the second example, if I see the value of a is -3 and the value of b is 12. Now if you see here, I will obtain after division -1/4, which is a fraction. And we know that fractions and decimals do not fall under integers. So this is not an integer. Let us look at the third example. For third example, we have -20 divided by -5. Remember, whenever we divide two negative integers, we get a positive integer or a positive number. So let's see here what we observed. We are getting 4, which is an integer. We will be learning more about negative positive integer division going ahead. So if you look at the last example, if I take a to be -5 and b to be -20, then I see two negative integers getting divided will give me a positive quotient, and the answer will be 1/4, which is again a fraction and not an integer. So we see here that the division property, the closure property for division holds only in some cases when we are getting integers, but whenever we are getting decimals or fractional form, then we cannot say that the division obeys closure property. So this will not obey closure property. So I hope you have understood the closure property for all the 4 fundamental operations. Now we will move to the next property, which is commutative property. So in commutative property, the property says that if a and b are 2 integers and we add them, then if we follow any order of addition, if we add a with b or b with a, we will always get the same result. So let us take an example and see. Here we have taken a to be 2 and b as 3. Let us add a and b, keeping a before b. So now we will get 5. Again, if I add in this way, b plus a, keeping 3 before a, then I will see I am getting the same answer. So commutative property holds for addition. Let us take another example. A plus b is equal to -6. Here again, b plus of a, which is a negative integer. This will give me plus minus -3. Different sign integers will get subtracted. 9 is greater, so its value will be +6. And here it will be +6 only, not -6, sorry. So in these two cases, you see 6 is coming out to be same. So this will hold the addition's commutative property. Now if we go ahead here and see, a is -5 and b is -6. So if I add a plus b, I will get -5 plus of -6, which will give me -5 -6. That is, same signed integers will get added, and this is negative addition, so we will have a negative sign in front. This gave me -11. Now let us see what do I get from b plus a. I will get something like this. Then I will at the end get 11 minus. -11 is the answer in both the cases. So The commutative property holds for addition. This rule is obeyed. Now, let us see for subtraction. Commutative property will never hold for subtraction. If you see here, I take two examples, like a and b are two integers, and if I take away a minus b, that is 7 minus 2 will give me 5. Now, if I want to do b minus a, then this will be 2 minus 7. This will give me minus 5. Why? Because this is positive and this is negative integer. And for negative integer, we have two different signed integers, we have to subtract, and after subtracting we are getting 5. But as 7 small value is greater, so we will have its sign before this number. So the commutative property does not hold for subtraction. Let us take another example. A minus b, where a is equal to minus 25, b is equal to minus 6. So a minus b will give me minus 25 minus of minus 6. So again I will get minus 25 minus minus plus 6. This will give me minus 19. Again if I do b minus a, what will I get? I will get minus 6 minus of minus 25. This will give me minus 6 plus 25. This is 19, which is positive. Here we have negative 19, here we have positive 19. We have a sign change, and sign change means the integers are different. So this is a negative 19, this is a positive 19. Here also commutative property did not hold. So the last example is a is equal to minus 30, b is equal to 25. Let us see. So we see here we have to add them, same signed integers. We got 55 preceded with minus because it is negative addition. Now again b minus a will give me 25 minus of minus 30. This is nothing but 25 plus 30, which is giving me 55. So the commutative property does not hold for subtraction. Let us move to multiplication now. Multiplication, if I take a as 5 and b as 6, then you can see here a into b will give me 5 into 6. That is 30. Again if I multiply b with a, I will get 6 into 5, that is again 30. So the commutative property holds for multiplication. Let us see two more examples. If a is minus 9 and b is 8, and I multiply a with b, then I get minus 9 into 8, which is minus 72. Again b into a is 8 into minus 9, which is also minus 72. Positive into negative, negative, and the numbers multiply to 72. Now, the third example is a is equal to minus 12 and b is equal to minus 6. So this will give me minus minus plus, and 12 6 are 72. Again b into a will give me minus 6 into minus 12 is equal to 72. Here also in all the three examples the commutative property was obeyed. Now if you see, if I multiply a with b, that is minus 5 with 0, then I get 0. Again b into a will give me 0 into minus 5, which is again 0. So in all the four examples, multiplication property was obeyed. So let us see if the commutative property holds for division. If a is 49 and b is 7, then if I divide a with b, then I get 7. But if I divide b with a, then I get 7 by 49, which is 1 by 7, and this is not equal to this. So the commutative property is not obeyed in division. Let us take another example. A is equal to 25, b is equal to minus 5. So here we will get two positive and a negative integers are getting divided. So we will get the quotient preceded with a negative sign. We will learn more about this going ahead. So taking the third example, here we have to find b by a also. If I find b by a, it is minus 1 by 5. So this is different and they are not equal. One more additional point to note here is that this is not even an integer. So again, a divided by b will give me minus 8 by minus 2, which is 4. Two negative integers when divided, they give a positive result. So it is 4, and b by a will be again a fraction, which is 1 by 4. So we saw that the commutative property holds only for addition and multiplication, but not for subtraction and division. After this, we will be covering the associative property. So what does the associative property tell? The associative property holds for addition, subtraction, multiplication, division. We will see which of these operations obey associative properties. So for addition, the associative property tells that if there are three integers a, b and c and they are integers, then if we add them in this fashion or in this fashion, we will obtain the same result. What is the difference between these two? I am taking the first two integers together and adding. Whatever result I am obtaining, I am adding that result with the third integer. And here I am adding the second and the third integer together and adding the result with the first integer. So let me see if the associative property is holding. A is 7, B is minus 13 and C is 24. So if I have to write in this formula, I can write like this: 7 plus of minus 13. I will put a square bracket here. This plus 24 for the left hand side. And for the right hand side, I have to put 7 plus minus 13 plus 24. So if you see here, 7 plus minus will give me minus 13 plus 24. So if we solve this, we will get different signed integers. We will have subtraction among themselves and the subtraction result will be 6 preceded with minus, as minus 13's mod value is greater than 7, and now we have 24 here. Again we are left with different signed integers. We again have to subtract. The result will be 18 preceded with plus because 24's mod value is greater than minus 6. Let us have a look here. Here again this will come out as minus 13 plus 24. So if I subtract these two, I'll get 11, which is positive because 24 is greater, and I'll get the answer as 18. So if you see, in both the cases, I got the answer as 18. That is, associative property is holding for addition. Now, let us have a look at subtraction. For subtraction, I have to subtract the integers in this fashion. What is the order? First, I have to subtract the first two integers, and then from the result, I have to take away the third integer. And on the right hand side, I have to subtract second and the third integer, and whatever result I will get, I have to take that away from the first integer. So let us see now. I will write in this fashion: A minus B minus C. A minus B minus C. I have used third bracket because we have to put minus 5 in first bracket. So the result will be 3 minus minus plus of 5 minus 11. I will get 8 minus 11. The answer will be minus 3. Now let us have a look here. If I write here, this will be 3 minus B will be minus 5 minus 11. So the answer will be 3 minus 5 minus 11. This will add and give me minus 16. The answer will be 3 minus minus plus 16. They will add and give me 19. So if you see here, this came out to be minus 3 and this came out as 19. Both of them are not equal. So hence the subtraction will not obey associative property. Let us have a look at multiplication. For multiplication, if we multiply first and second integers and then the product we are multiplying with the third integer, then that should be equal to the result which we are obtaining here when we are multiplying the second and third integer and obtaining the product, multiplying that with the first integer. So let us take the values and explain. So I will write in this pattern minus 3 into b is minus 5 into c is 6. And here I will have to write minus 3 into b is minus 5 into 6. So here I will get minus into minus plus, and 3 5s are 15 into 6. Again here I will get minus 3 into minus into plus is minus 30. Here I will get 90. Here also I will get 90. Minus minus plus 3 30s are 90. So in these case I saw that in this case 90 is coming on both the sides. So multiplication will obey the associative property, but subtraction will not. Let us have a look at division. Now, if I divide the first number with third one, and whatever quotient I am getting, I have to divide that with third number or integer. That should be equal to the result which I am obtaining after dividing the second integer with the third integer and taking their quotient and dividing the first integer with that. So let us see. A is 48, B is 12, C is 2. So if I divide A with B and I write in this pattern, then I have something like this on the left hand side, and on the right hand side I have 48 divided by B divided by C. So here if I see, I obtain 4. 48 divided by 12 will give me 4. This when divided by 2 will give me 2. Now again here 48 divided by 12 when divided by 2 will give me 6. 48 when divided by 6 will give me 8. So you see 2 and 8 are not equal. So associative property will not be obeyed here. Now you have seen closure property, commutative property, associative property. Now we will see a special property which holds only for multiplication. If you see here, I have written multiplication is additive over addition and multiplication is additive over subtraction. So what does this mean? Let us go one by one and understand. So if A, B and C are 3 integers, then if I multiply A with the sum of B and C, then I will obtain a result which will be equal to something, the result which I am obtaining from this equation. So the result from this equation is A into B plus A into C. How I am obtaining this? I am multiplying this A once with B, putting the positive sign or the addition sign. Again I am multiplying A with C. So let us check with the values if this is holding. So for A we have 5, and for B and C we have minus 3 plus of minus 7. So let us solve the left hand side first, then we will solve the right hand side. So if we see here, 5 into this will be minus 3 plus minus will give me minus 7. So this is 5 into minus 10, which is minus 50. Now let us solve the right hand side. The right hand side will look something like A into B plus A into C. So this will give me 5 3 15 plus minus minus, then again plus minus minus, 5 3 7 5s are 35. So I will get again minus 50 here. So if you see, both the results are same. So this is the distributive property of multiplication over addition. This is a very important property and this helps us to calculate easier, so we should remember this property. Now let us see how multiplication is distributive over addition. How can we distribute the product and add them or subtract them? If A, B, C are 3 integers, then if the difference of 2 integers is multiplied with the first integer, then I will get the same answer as when I am doing the first integer multiplied with second integer minus the product of first and last integer or third integer. So let us take now with the help of an example. I will write in this pattern 5 into b is minus 3 and c is minus 6. Now let us see what do I get. 5 into this will be minus 3 minus plus 6. This will be 5 into 3 which is giving me 15. If I go here and write in this pattern, then it will be a into b minus a into c. It is better to use third bracket or square brackets so that we don't make mistakes while multiplication of sign. So if you see here, 5 into minus 3 will give me minus 15 minus this will be 6 5s are 30 and plus minus will give me minus 30. So now I have minus 15 plus 30. So I have 15. Here also I obtained 15, here also 15. So this property is holding for subtraction as well. So now we have covered the distributive property of multiplication over addition and subtraction. Now we will see the next topic, which is additive identity. What is additive identity? Suppose for any integer we call 0 as its additive identity. Why? Because if I add 0 with any number, I will be getting the same number itself. If I add 0 with that number, keeping the number before 0 or keeping 0 ahead and the number after, I will be getting the same value. For example, if you see a is an integer, if I add 6 with 0, I will get 6 only. Or 0 with 6, I will get 6 only. This was a positive integers example. Let us take an example of negative integer. So if you see, minus 7 plus 0 will give me minus 7, or 0 plus of minus 7 will also give me minus 7. So this 0 is known as the additive identity. So what is the additive inverse now? For any integer a, there exists another integer such that if we add that integer with a, we will be getting 0. How do I say that? If I have an integer, say 7, then the additive inverse of 7 will be minus 7. Why? Because if I add 7 with minus 7, that is, this will give me 7 plus minus 7, it will give me 0. Again, the additive inverse of minus 8 will be simply plus 8, but we don't write plus, so it will only be 8. If you see here, minus 8 plus 8, if I do, then these are different signed integers, they will get subtracted and their values are same, so it will give me 0. So 0 is the additive identity, and to obtain additive inverse, it will be the same number with the sign changed. If it is positive, it will become negative but the same number, and if it is negative, it will become positive but the same number value will remain. Now what is multiplicative identity? For every integer a, we call 1 as the multiplicative identity, because after multiplying any number with 1, we will get the same number. If we keep 1 before a and multiply, or 1 after a and multiply, we will get always a. For example, if you see here, I have taken a is equal to 7. If I multiply 7 with 1, I will get always 7. Or if I multiply 1 with 7, then also I will get 7. If I take another negative integer, if I multiply minus 8 with 1, I will get minus 8. That is the integer itself. Or 1 with minus 8, then also I will get the same value. So you have now understood additive identity, additive inverse, multiplicative identity. Now let us move to some important points which we need to cover for multiplication and division. So for multiplication, whenever we are multiplying two positive integers, we will get a positive integer. When we are multiplying a positive and a negative integer, we will get a negative integer. And when we are multiplying two negative integers, we will get a positive integer. I hope you know this rule. Again, I have explained this once more. Now, if any integer is multiplied with 0, we will get 0, be it positive or negative. So, in both the cases, you see I am getting 0. And one most important point here is product of 3 negative integers is a negative integers. For example, if I multiply -2, -3 and -8, the result will be negative. I don't have to multiply minus minus plus, then plus minus minus will give me minus. Simply by looking at this, we see that there are 3 negative integers. The value will be -48. Now, if you see here, if I multiply here -2 into -5 into -10 into 8, then the result will be minus minus plus, plus minus minus, minus minus plus. So the result will be something positive and it will be 800. So if you notice here, when there were 3 negative integers, we obtained a negative number. And when there were 4 negative integers, we obtained a positive number. So what is the difference? And one point to note here, if we are finding the product of odd number of negative integers, then we will get a negative integer. But if we are finding the product of even number of negative integer, then we will always get a positive integer. Please remember this point carefully. We have to get a negative integer, and we will get negative integer only after multiplying odd number of negative integers. And by multiplying even number of negative integers, we always get a positive integer. So now a special case for -1 is if we multiply -1 odd number of times. Here if you see, I am multiplying it 1, 2, 3 times, and 3 is odd. So I will get the number itself 1 and a negative sign before it. That is, I will get a negative integer. Now again, if I multiply the same integer -1 4 times and 4 is even, then I will see that I will obtain the number 1 itself preceded with no sign, that is positive. So here this property was obeyed. -1 when multiplied odd number of times, we get -1, and -1 when multiplied even number of times, we get 1. So now, some important points for division. If we multiply 2 positive integers, we will get a positive integer. If I multiply a positive integer, if I divide a positive integer with a negative integer, then I will get, firstly I will perform the normal division. Then I will add a negative sign before it. And if I divide a negative integer with a negative integer, first I will perform the normal division and add a positive sign or no sign before that integer. And you obtain here another one point, which is if a negative integer is divided by a positive integer, then also we will get a negative integer. In all these cases, you have to divide the numbers simply like we usually do in normal mathematics. Just the sign you have to keep using this formula. You have to keep in mind how we should put the sign in front of the quotient following these 4 rules. Now, if A is any integer and it is divided by itself, it is divided with 1, then we get the integer itself. For example, if you see, if I divide 3 with 1, I get 3. Or if I divide -2 with 1, I get -2. And if any integer when divided with -1 will give me minus of that integer. For example, if I divide 3 with -1, I get -3. Why? Because a positive is getting divided with negative. So I will perform the normal division first and then add a minus sign before it. Again, if you see, -3 divided by -1, 2 negatives when get divided, it will give me positive result and the answer will be 3. So this 3 is positive 3 and it is nothing but negative of this 3. So the answer we are obtaining in this fashion only and also obeying this rule. Any integer divided by itself will give me 1. For example, if I divide 5 with 5, I will get 1. If I divide minus 5 with minus 5, I will also get 1. Two negative division integers when divided give me positive sign and the number. Any number when is divided, when it divides 0, it gives 0 as the answer. For example, if I divide 0 with 2, I will get 0. 0 with minus 5, I will get 0. But one very important point to note is that any integer cannot be divided with 0, and this is called as undefined. We cannot define any such division. For example, if I divide 5 with 0, this will not hold. This will be infinity. Or it is undefined. I cannot divide any negative integer also with 0. In both the cases, I will obtain something, the result which is undefined. So we have covered all the topics which I have mentioned in the lecture before covering these topics. If you have liked this video, please like, share and subscribe to my channel, and please press the bell icon to get notified about all my videos. If you have any doubts or comments regarding this video, please comment down on the below section. We'll meet you in the next video covering exercise 1.2 from the chapter Integers from the book ML Agarwal. So till then, bye.